Welcome back to our FRQ series for the 2021 Calc AB exam. This is question 5, no calculator allowed. The links to the FRQs as well as the scoring guide are in the description. Consider the function y equals f of x, whose curve is given by the equation 2y squared minus 6 equals y sine x for y is greater than 0. Before we jump into the solutions, go ahead and give your best shot at these problems, then come back once you're ready. Alright, so jumping into part A, it wants us to find dy over dx. Here, we're actually given the solution and we're asked to verify it, so this should be a relatively easy point to score. So let's find dy over dx. Remember that when we implicitly differentiate, we need to multiply each non-x term by dy over dx because of the chain rule. The derivative of 2y squared minus 6 is 4y dy over dx, and the derivative of y sine x can be found using the product rule, and this will look like dy over dx times sine x plus y times cosine x. Our result will be 4y dy over x equals dy over dx times sine x plus y times cosine x. Now in order to find dy over dx, we need to isolate dy over dx, and then we can verify our answer up here. Part B wants us to find the line tangent to the curve at 0, root 3. It already gave us the point, so all we need to do for this one is find the slope using dy over dx and then find our equation. So let's do that. Let's just rewrite dy over dx from the previous part so we know what we're working with. Plug in 0 for x and root 3 for y. And if we solve it out, we get that dy over dx, or our slope, is 1/4. Now that we have our slope and our point, we can plug in our values to get the equation for the tangent line. Part C wants us to find a point where the tangent line is horizontal. This means we have to find when the slope is 0, so we have to plug in 0 for dy over dx. If we do that, we're left with y cosine x equals 0. To find x, we actually have to look at this y is greater than 0 up here. This means that y cannot equal 0, and the only way this equation would be true is if cosine x was equal to 0. So if we find this, we get that x is equal to pi over 2. To find y, we simply plug in our x value into the equation that the problem gives us. After doing some algebra, we're left with two y values, negative 3 over 2 and 2. And again, since we're told that y must be greater than 0, we know that 2 is the correct y value. So our coordinate point is pi over 2, 2. Part D wants us to find whether f has a minimum, maximum, or neither at pi over 2, 2. So for this one, we're going to have to use the second derivative in order to find its concavity. That way we can tell whether it's a minimum or maximum. We can see that we're given dy over dx in the u over v format. So I'm going to use the quotient rule to find the second derivative, but if you like, you can flip the denominator into the numerator by raising it to the power of -1. As you can see, this problem is extremely short, so this should not take long. Of course, I'm just kidding. I sped up the video so you don't have to watch, but you should really be extra careful with these long problems since it's really easy to make simple mistakes. And I'm mainly talking about your plus and minus signs. And once we're done, we should be left with -2/7. Since we want to know the concavity, the number itself isn't really important. We're just dealing with the sign in front of the number. And since it's negative, we know that f will be concave down at this point, which means f will have a relative maximum at this point. So that's all there is to this video. Again, the links to the FRQs and the scoring guide are in the description. If you still have questions, you can leave them in the comments. If not, I'll see you in part 6.